Hi, my name's Eric Jordan with Nisene Technology Group. We've been in business for over 30 years, primarily, majority of those years manufacturing our Nisene jet etch for chemical decap. However, with market changes, we've adapted our chemical processes as well as introduced the Nisene PlasmaEtch. The Nisene PlasmaEtch is a microwave-induced plasma that uses a focused downstream plasma discharge. Now, because we're a downstream plasma, we're able to greatly reduce the effects of ion bombardment as well as the heat index typically found in traditional plasma processes. Within the system itself, all of our gases are controlled using mass flow controllers. That allows us unparalleled control of each gas down to 0.5 SCCM or the complete removal of a gas from your recipe. These gases are also controlled using auto-tuning, which means that regardless of the micro adjustments you can make to the recipe, you can ensure that the plasma is going to be generated in its most optimal state. This requires no hands-on changes from the end user. It's all self-controlled within the system itself. And the benefit of this is that your system, with that, you can guarantee your sample is run in the most optimal state from start to finish. So this would reduce your overall processing time of each sample. Within the system itself, a sample can go unaltered for a complete decap down to the exposure of the bond wires and the die surface without any chemical finishing required. The system itself has a 200 millimeter diameter process chamber with a viewport seen here. Because we have such a large chamber, you're able to fit large-scale samples, multi-chip modules, chips on boards, and others, with plenty of room to adjust where your cavity is for your opening. The entire process is run 100% in a vacuum. This eliminates the unknown potential for contaminants found in atmosphere conditions. All of our processes are run between a range of, or almost all of our processes are run between a range of 35 to 50 watts of power. And in this power range, you're able to greatly reduce the potential for heat index as well as electrical damage that can be traditionally found, which means your sample is less likely to be damaged during the decap process. And if you take a look at the slides here, you'll see what a more standard decap looks like using a gasket to seal for your cavity. Most people are familiar with what a traditional chemical cavity looks like here. The purpose being the gasket needed to seal for your exposure. Where applications can create problems is with large chip scales where you have a limited sidewall to ensure the sealing of your gasket, as well as multi-chip modules, which are starting to become more common with examples in like a smartwatch or a Fitbit type module. Other advancements where you'll see the PlasmaEtch excel greatly is with the exposure of second bonds or stitch bonds. Fully exposed bond wire can be very fragile in nature, but because the PlasmaEtch process is a much more gentle environment, we're able to repeatedly maintain the full exposure of a bond wire repeatedly over many samples. The end user can also expect to see repeatable and intact results for copper bond wires, palladium coatings, as well as silver wires. Because the industry is always changing with the advancements of products and the requirements those products need for testing, companies need tools in order to meet that versatility. Now with the Nisene PlasmaEtch, we're able to establish repeatability and the versatility needed to adapt to the growing demand of different technologies in the market today. Nisene staff will be on hand at the ISTFA 2016 for the next 2 days. We'd be more than happy to discuss your specific application, or if you'd like to arrange for samples to be sent, we'd be more than happy to process samples for you. Thank you for attending.